This is the answer key to the spiral on solving equations. I'm not going to check, I'll probably check the first one, but after that I'm not going to check. In terms of the check, that's just your way of determining if it's correct or not. So I'm not going to go over that. That would be your responsibility, and I would certainly suggest you doing that when you take your actual spiral. Let me just go through these and actually solve them. In terms of solving equations, step one is I like for you to clean up each side. In other words, combine any like terms. If you look at number one, there's no cleaning up on either side. Number two, there's no cleaning up on either side. But number three, we have some cleaning up to do. That includes the distributive property and then combining like terms. On the right side, nothing to do. So we'll have to clean up each side. Once we're done with that, we move on to step two, which means we need to have variables. Let me phrase it like this. Variables on only one side of the equal sign. Now that's the issue we run into with 1 and 2, and certainly 3 also. Let's start with 1 and 2. Variables on both sides, got to get rid of one of them. I'm going to take away the 6r, goodbye, 6r, goodbye, 6r. That's the subtraction property of equality. 7 equals 13 plus 7r minus 6r is r. Minus 13 minus 13, r equals negative 6. If I were to check this, I'm only going to check the first one. Everything stays the same, except instead of the r, I put the number in negative 6. And I evaluate and see if I get the reflexive property at the end. This is negative 36 plus 7, which is negative 29. This is 13 plus negative 42. 13 plus negative 42, they fight. Negative 29 equals negative 29. Reflexive property. Question number 2. Again, I don't have to do cleaning up on each side because it's already cleaned up, but I do have variables on both sides. Oh, I'm sorry, I do have some cleaning up to do. Didn't realize that. Negative 8 minus x, didn't see that, equals x minus 4x is negative 3x. Now I've cleaned it up. Now I got to deal with variables on both sides. I'm going to get rid of this one, plus x plus x. Negative 8 equals negative 2x. Negative 3 and 1 is negative 2. Divide each side by negative 2. Again, that's the division property of equality. X equals negative 4. I'm going to switch them. X equals negative 4 like that. And when I switch sides like that, that's called a symmetric property. Just a review of properties while I'm here. Number 3, plenty of cleaning up to do. Got to distribute whoosh whoosh. Negative 8n plus 4 plus 20n minus 6n minus 14. Equals negative 6n minus 14. Still more cleaning up to do. This is positive 12n plus 4 equals negative 6n minus 14. Variables on both sides, plus 6n plus 6n. 18n plus 4 equals negative 14 minus 4 minus 4. 18n equals negative 18. Let me go over here. 18n equals negative 18. Divide by 18, division property of equality on both sides, n equals negative 1. For number 3. Number 4 introduces the concept of a fraction. You can certainly deal with problems that have fractions. I would suggest multiplying by the reciprocal, but even if you didn't want to do that, you could just multiply by just the denominator, the 4 on that side and 4 on this side. That's 3 times x plus 6 equals 24. You could do this, and you distribute whoosh whoosh, 3x plus 18 equals 24, minus 18, minus 18, 3x equals 6. Divide by 3, divide by 3, you could get x equals 2. If you had decided to multiply by the reciprocal, x plus 6 equals 6, and you multiply by the reciprocal right off the bat, times 4 over 3 times 4 over 3, then it totally cancels, you just have x plus 6. 6 times 4 thirds, if I want to do this on the side, this is 6 over 1 times 4 over 3. 6 over 3 cancels to 2 over 1, 2 times 4 is 8. Or you could just multiply straight across. 6 times 4 is 24, 1 times 3 is 3, 8, it equals 8. Minus 6, x still equals 2. So it's the same thing, no matter how you do it. But you got to get rid of that fraction first. Could you have distributed the fraction? You certainly could have. You just would have made things a lot messier for yourself. Number 5. Again, some cleaning up to do. Not a lot, but some cleaning up. Negative 10x plus 2 equals negative 8x minus 8. Variables on both sides. I'm going to add 10x. The opposite of negative 10 is positive. Add 10x. 2 equals negative 8 and 10 is 2x minus 8 plus 8 plus 8. 10 equals 2x. Let me use the symmetric property. 2x equals 10. Divided by 2 divided by 2. X equals 5. Number 6, once again, is going to ask us to clean up each side. They both have the distributive property. So I can distribute whoosh, whoosh. 3 times 1 is 3. 3 times a negative 3x is a negative 9x equals whoosh, whoosh. 2 times negative 4x is negative 8x. 2 times 7 is 14. Variables on both sides. I'm going to, let me add 8x here and add 8x here. This will make it a little bit harder, but that's okay. I want to show you guys what happens often. Negative 9 and x is a 3 minus x, or negative 1x. At this spot right now, it gets tricky. Students will often add 3. If you add 3, unfortunately, adding 3 and another 3 is 6. So you should not be adding 3. If 3 is positive, I get rid of that positive 3 by subtract 3 and subtract 3. On this side, I have 11, but here's the next trick. I don't have an x, I have a negative x. So the x is what was negative. So negative x equals 11. How do I undo this negative, or negative 1? Divide by negative 1, divide by negative 1. X equals a negative 11. It's a trickier one. If you had got rid of the negative 9x by adding 9x to both sides, it would have been a little bit easier. But you still need to know how to deal with problems that look like 3 minus x equals 14. Again, this is more of a two-step than you believe. You subtract 3, subtract 3. We have negative x equals 11. If a negative x is 11, that means a positive x is a negative 11. You just do the opposite. Last 2 questions. Got some cleaning up to do. This one's tricky because you think it's just minus a y. A lot of students do 3y minus y plus 4. That's, of course, not correct because that would not be subtracting the entire quantity. That's just subtracting the y. You got to subtract the 4 also. In other words, this is the distributive property. Whoosh, whoosh. Distributing a negative 1. You might say that's a subtraction sign. It's also a negative 1. Negative 1 times y is negative y. Negative 1 times 4 is minus 4 equals 4y plus 12. Cleaning up. 2y minus 4 equals 4y plus 12. Still have variables on both sides. Got to get rid of one of them. Goodbye to the 2y. Goodbye to 2y. Doesn't really matter. Negative 4 equals 2y plus 12. Minus 12 minus 12. This is keep, change. Negative 16 equals 2y. I'll use the symmetric property, move it over here. Divide by 2, divide by 2, y equals negative 8. For number 7. And for number 8, again, some cleaning up to do. Let me distribute. Negative 4 times x is negative 4x. Negative 4 times a negative 1, and negative times negative is a positive 4. Negative 2 times 2x is negative 4x. Negative 2 times negative 3, and negative times negative is a positive 6. Variables on both sides, you might see what's happening right now, so this is the same. Doesn't matter which you get rid of. Add 4x, add 4x. I have 4 equals, well, these cancel also, 6, which is not true, so the answer is no solution. If it were true and it was like, let's say 64 equals 64, that would be all real numbers. But since it's not true, 4 does not equal 6, the answer is no solution. You obviously cannot check if there's no solution, and you can't check if it's all real numbers either.